All right. Okay. So let's get started. Okay. So welcome to the last community meeting of this year. I can't believe um it's December already. Um so last month we had a bit of hiccup, because we were at KubeCon. And so this year so this month we're gonna half of our team is in Japan at this moment. So we'll do it from here. Um, from Tokyo. And we have three items on the agenda today. So first, we're going to talk about the release point 13.5. So that's Hydai going to give us overview of what's in that release and what to look for and things like that. And then I'm gonna do a little demo of a new AI tool that we put together to run large language models, but with all-in-one script that allows we're going to promote this maybe in the next week or so. So that allows people with a single command to chat with any open source large language model. And then Vincent gonna give a brief presentation of how to run um, the the WasmEdge AI plugins in the Docker environment, in the container environment. So yeah, so Hydai, please, perhaps we can start with you. Let's talk about the new WasmEdge release.
Sure. Hello everyone. Can you see my screen now?
Yes.
Okay, great. So today I'm going to talk about the 13.5 release, and in this last 13 version, we introduce a powerful plugin. We call it the WasI neural network with the llm.cpp backend. So with this, this backend, you can now, load the large language model into load the large language model with the WasmEdge spec. And because there is an extension called the neural network preload option, so whatever your model is 10 gigabytes, 20 gigabytes or more, it will no longer be limited by the Watson 32 bits limitation, which is allow you to load something small than the 4 gigabytes. So with this plugin now, this limitation is just gone. Okay, and we also enable two backend support like CUDA and Linux and Metal Framework and the Mac OS. So if you have the CUDA 12 installed on your Linux server, when you run our install script, it will detect there is a CUDA framework is installed, and it will try to use our plugin with CUDA enabled. And if you are using Mac OS, uh, especially you are using the Apple Silicon model, then the Metal framework will be enabled by default. Also, in this version, we support you can compile WasmEdge with the Microsoft Visual Studio now. Before this version, there are lots of incompatible because the tool chain from GCC and LLVM is not exactly the same as the MSVC. So in this version, we do lots of stuff. Thanks for the Menti, and he actually, you know, uh, almost rewrite the SIMD part because using the vector instruction is totally different from the GCC and from the MSVC. Yeah. So that's our big change in this version. And also we have initialized the ZZip support, and it's a alpha feature. So if you're interested, you can go to try it. So the first important one is that we also have a new C API, which provide you, to put your large model with our SDK. So we call it the plugin in it was neural network, and there is only one parameter which is allow you to set your preload tuple, which is your model name. You can alias it in any name you want, but you have to specify it in the the WASI neural network spec to identify which model name you want to load it. And the second one is the model encoding. Actually, it's the backend. For example, the llama.cpp is ggml, and if you are interested in using PyTorch, you just put PyTorch here. And the third part is the hardware target. However, we suggest you to use auto instead of CPU or GPU, because that just as I mentioned before, if you are install the the CUDA version, then we will by default make the CUDA enabled. So whatever you specify here is not important at all, because that the backend will detect the fast way to run it. And the last part is your your model path. For example, this one is the Llama 2 TB chat model. Okay. And yeah, thanks to our mentee, Wan Jikai, and he do a fantastic job to make our WasmEdge can be built on Windows with MSVC. If you're interested, you can just check the workflow to to know how to use MSVC to build it. And if you are interested in how to use it, or how it did, you can go to the pull request directory. You can check lots of stuff here. Also, let's talk about the Llama the CVV support. I believe most of the model now, we are verified that you can use it with our Llama utilities. You can check this link, and I believe Michael will give you a total demo of this part. So let's just skip it. But if you are interested, we actually already integrate several different models, so you can go to there and check out by yourself. Also, we extend the WASI neural network spec. So now you can set some hardware related metadata before load the model. Because when let's say when you have a model, you want to load it into your GPU. However, the model may be very large than your your VRAM. So it's not possible to fully load the layer of tensor into your GPU. You have to reduce the number and put some part in your GPU and some parts on the main memory, and to use it. So if you want to specify it, you must do it in the metadata way. Just before you initialize it. Yeah. So in this version, we add the metadata support. Also, if you're interested, we have several different table. If you're using Ubuntu, you can have the CUDA enabled, or I believe currently we have the Open Plus enabled version if you only have CPU. And we encounter several repo, which is when they try the many Linux version, it may not work like unlike like Debian or any new distros than the CentOS 7. So you can try to specify the your distros with Ubuntu 20.04, to get this new one instead of the Center OS 7 one. Okay. And for Windows, actually we don't have any native builds for Windows. So if you want to try it on Windows, please use WSL2 for now. We may build for it once we have free time. I don't know it's when. Okay. And we already verified this plugin on several platforms like the NVIDIA Jetson, Orin, and the Intel CPU plus old GPU card. This is pretty old. And also we tried on the on the AWS. So if you're interested, you can create a A10G GPU model on AWS cloud and try it. Yeah. Also, there are some community repo. They try the 1419 and have a pretty great TPS here. So here is our performance table, and we are working on a new repository that's allow users to upload their own result to our to the repository, and we will announce it maybe next week. And if you're interested, you can run any model on your platform with your own hardware, and you will get the number of TPS, and we are you're welcome to upload it to the performance table. Yeah. Okay. So yeah, the last one is the ZZ support. If you're interested, just go into this pull request, and you can find which function is already defined, and you can try it. Yeah. So that's all my presentation. Thank you.
All right. Thank you, Hydai. Yeah, that's I thought that was very interesting, because one of the consistent feedbacks that I got is the cross-platform nature of using WasmEdge to run a large language model appeals to people because, if you think about it, in today's Kubernetes cluster, there are a complex set of hardware and operating systems, especially with AI workloads. You have different GPUs and accelerators and all that. Even there's newer CPUs has their own software frameworks like the one Intel has, right? To run inference directly on the CPU. So to have a portable layer that is also very performant is allows those AI inference workload to be distributed and managed easily across the clusters. So but that leads to our next two topics. So first, what I want to show you is a tool that we have developed because so far we have different repos and different applications and different instructions in terms of how to run those large language models. But what I want to show you today is all-in-one tool that allows us to let me load up this page. All right, so let me share my screen. I'll share the whole desktop. Okay. All right. Okay. So this is a web page. If you want to follow along and try it on your own computer, this it's called secondstate.io run-llm. So if you go to this web page, essentially it's just one single command, and it does everything for you. Here are some videos, but what I'm going to do is that I'm going to just show you how it works. So so this is a command that you just see from the from the web page, right? So what it does is that curl, it gets this script and then run it through the Unix shell, okay? So when you do that, the first question it asks is, how do you want to install WasmEdge? And since I already have WasmEdge installed, I would just skip and to say keep my current installation. Then give me a list of the models that we have tested. So for each model, there's a slightly different command to run it because the model typically requires a different chat template. How do you structure those, chat messages that in history? And sometimes it needs parameters such as, when certain tokens were encountered, it's going to stop generating, things like that. So there's a large number of, well, the last time I checked Hugging Face, there's 2,000 Llama 2 fine-tuned models, So there's a huge number of data sets and different ways people fine-tune Llama model. Even we have done that. I showed one at WASM Day in Chicago, about fine-tuning a Llama 2 model to understand WASM, right? So you can ask it questions about WebAssemblies and WasmEdge, but I would be able to answer it. We call it Lava at the moment, and we had a lot of fun, at that conference. But the point is, there's many ways to fine-tune a Llama 2 model to make it behave the way that you want it, right? So here are just some of the more popular models. And a lot of those, as you can see, deals with coding, right? So it helps you with coding stuff. So you can select any of those models by picking a number. And I'm gonna just pick the most, the Llama 2 7B model. This is if I haven't downloaded it is going to download it. But since I already have it, so in my local directory, so it's gonna skip and then go to the next question. So the next question bifurcates into two options. You could run the model through a command line interface, or you could create an API server. We're gonna do both, but we're gonna do step by step. So in the first demo, we're gonna just run from the CLI, and it asks, do you want the login information? No, so I want a more clean experience. So what it does is that it downloads the inference application. Like I just said, the inference application is completely portable. So basically, it downloads a WASM file that is about one megabyte, and you can run it in any device that is supported by WasmEdge. So in this particular case, it runs entirely on my machine here, on my MacBook here. As Hydai said, you can run it on the. So we have an edge device which is a Jetson server. It's about this big. It's about the size of my hand, and it's larger than the Raspberry Pi, but it's still pretty small. It has NVIDIA GPU on it, so we put it in the office, and you can easily run it there as well. So you can run it on the cloud-based GPU servers and things like that. So now that's so now the model starts, and I can chat with it, so to speak, from the command line. So it would be say, where is the capital of Japan? Okay. So the results come back pretty quickly. That's again, it's a 7B model. It's a real large language model that's running on my laptop, right? While I'm still having conference call with you guys, right? So the capital of Japan is Tokyo. That's correct. But I also heard, what about Kyoto? Kyoto is a city in Japan, but it's not the capital, which is correct too. I can follow up to say, wasn't it the capital in the past? It's oh, so obviously here's wrong. That's but I think this is correct. So it's those are pretty the large language models. So that gives you the reason why you want to fine tune it, right? Or build a RAG interface around it, so that it doesn't hallucinate like that. And you can also ask a more complex question. Say, please plan a 2-day visit to Kyoto for me. Okay, so it's gonna give you itinerary. That's go to this shrine, go to that temple. Day one, day two, and things like that. It was all, I think, you know, it's generates pretty fast. It's faster than I can speak, right? If I were to read it, I wouldn't be able to follow it. Again, this is I'm running on a I would say fairly low end Mac laptop. When I bought this Mac laptop, there was no large language model. I thought I was only going to use it for word processing and remote programming. I never thought I would really use the computing devices on top of it, right? But here you go. That's so I'm having a conference call, I'm having video recording, and I'm having a Docker container running, and at the same time running a large language model like this, and it's at pretty reasonable speed. So I'll exit out of it. So I Control C, and I'm gonna run the program again. And this time I'm gonna show you the web UI. So keep my own WasmEdge installation. Use the file I already downloaded. Create an API server. Okay, so what it does is that it downloads the Wasm application. That is that's because in WasmEdge, we have advanced sockets. So we can support multiple concurrent clients. So we can start a real web server with multiple client connections. In this way, the web server can provide an API service. So the API service is structured the same as the OpenAI API. So you can have the OpenAI formatted JSON to it, which I wouldn't show that to you right now. However, with the API service, we can also serve HTML and JavaScript format. So if you go to this local host, if you open a link, it would actually open to a chatbot UI. If you look at the address bar, it's actually connecting to a server running inside WasmEdge on my own local machine, on my own laptop, right? So it serves the HTML and JavaScript. And it's what it does is that when I interact with it on this web interface, it would use the large language model that's loaded into that WasmEdge application. So I will ask the same question: what is the capital of Japan? So the answer comes back pretty quickly. It's Tokyo. One of the drawbacks is that it doesn't do the streaming output anymore, because one of the limitations of the WasmEdge is that you have to wait for the entire answer to come back. You can't to have a buffer, to have a function right into the buffer. However, we're trying to find solutions for that, because the user experience would be much better if it is streaming back, right? So I can ask a follow-up question: how about the United States? This clearly shows it follows conversations, right? Because without the previous history, what's the capital of Japan? If my first question is how about the United States, there's no context. What about the United States? What am I asking? Only with the first two questions that the model knows that I'm actually asking how about the capital of the United States, and it answers that correctly as well. Then I can ask follow-up questions. So maybe I'll try to confuse it a little. I thought it is New York City. Typically the model would apologize and say, I'm right here. Let's see if it does. Oh yeah, so the model, you can see those large language models often hallucinate if you don't align them. That's why there's a need for fine tuning, right? So that's also why the open source LLMs are so popular, because you can fine tune it in a way that is very strong in a very specific domain. So for instance, you can fine tune it for the geography, right? So that it wouldn't easily be swayed by the user's opinion anymore, right? So there are lots of things you can do. That's to have your fine-tuned model that hallucinates less and has more domain knowledge, running on your own machine or on the edge server somewhere, or have it running in the database. And because of its it has a provider API server. It is one of the projects we are currently working on is to have it integrated with LangChain and Llama Index, those RAG frameworks, so that you can do things like send it the PDF and have it and chat with the PDF, send it with a code base and chat with the code base, and things like that. So there's when you open up the large language model and have and have the ability to run them on your on your own machines, either localhost or edge device, you would have a lot more flexibilities. That said, so going back to the comments that I made earlier, one of the chief benefits people see, at least that's what our customer has told us, is that the portability is really one of the features that they want most. And why they want portability? Because they want the model inference application to be deployed in a complex cluster environment, so that the orchestration framework or the management framework doesn't have to distinguish, which device, the application is deployed on. Does it have CPU, the x86 CPU or the ARM CPU, or which generation of the Intel CPU it has? Does it have CMD or AVX, or does it have the NVIDIA GPU, or is it a Mac? It'll be the same application everywhere. And to that end, we would need to enhance our the WasmEdge integration with Kubernetes and the container management tools to that would allow them to support the plugin system, especially the WasmEdge plugin system. So that's so I would hand over to Vincent to show you some of the work that we have done. That's that we would hope to get merged back with Docker and with Sierra in this area. So Vincent, please.
Okay. Wait a moment.
Okay, let me stop sharing so that you can. Yeah. All right.
Yeah. Everyone see my screen?
Yes.
And hear my voice. It's okay. Okay. I change my screen. Wait a moment. Oh. Okay. You want to see my screen? Okay. Today I will show you how to run Watson with Llama application in Docker environment. Currently, the Docker's use the Docker's Watson runtime use run Watson structure, but the GGL plugin support rely on plugin system. Yeah, so in this visual is now ready with the static view WasmEdge runtime string in Docker environment. So today, the demo I will use our fork run Watson to run. Yeah. Okay, let's go. Yeah. The whole comments in a sandwich this page here today. The demo. If you want to reproduce our demo at the community meeting, you can check out our video link in our poster here. Yeah. The comment in the sandwich page. Yeah. explain why every step is doing. Yeah. The first one is the download model. Of course, you need a download to the host. But because of that the model is too large, so I already download before a meeting. So in here, you can check this. The second one is install a WasmEdge string and plug into the host. I already built a preview the runtime in the bundle binary and the dependency library into the image. Is the cluster. So if we want to install the WasmEdge string for the GGL plugin, you just type this command. So after you install a WasmEdge string, you can trigger our host path. After this, the string will install our OPT container define thing on the path, and the dependency library will be here. Yeah. So you can check our WasmEdge plugin will install here. The next steps in how to run Docker environment. This command in here. Actually, for runtime, we need to ship our library to our WasmEdge runtime and ship the model into container. So we need to find the path to container and find the model path into resource folder. And we use this environment variable to tell our runtime to know where is the plugin parameter library, and our preload plugin preload model configured in here. And finally, parameter in the same with our WhatsApp application in using here. So if you want detail, the option here. So I just copy a command and then run. Yes. Yeah, streaming output in here. So yeah, it's how to run the WhatsApp with normal application inside Docker environment. So if you want to check command, you can check out the video again. Okay. Now about in the content I should do. Then you can hosting back to Michael. Hi, Michael.
Okay, yeah, thank you. So yeah, so all this work would be submitted back to the run-llm team to be merged back into Docker Desktop. Is that understanding correct?
Hi.
All right, yeah, that's we have a lot of things going on, that's especially around the large language model stuff, but we also have a lot of I would say more traditional microservice stuff as well. So like Hydai said, we're gonna have a GitHub repository that would collect the performance numbers of all those things. So let me look into the chat message to see if there's anything I can that I can answer. So Okay. Okay, so I saw some questions has already been answered. Yeah, so when it's running locally on your own hardware, you don't need to pay, right? When I say the Open API compatible API, you can send the Open API request in here, but obviously you don't need the API key anymore, and you don't need to pay anybody because that's your own device, right? So running on your own device has this benefit. Maybe it's a great benefit I forgot to mention is that our by the way, our OpenAI builds, we were using OpenAI for a variety of internal projects. From some of you may know that we review every single PR using OpenAI, use ChatGPT, and we use ChatGPT to do code, to help us write code a lot as well. Our bill is several $100s, sometimes over $1,000 per month. Okay, money just spent on OpenAI. By moving those to specialized models that are running locally or our own hardware, is really going to go a long way of cost saving. So that's one of the benefits that I didn't even mention. So yeah, that's So Jay asked, what's the performance loss of running Llama in WasmEdge versus running llama.cpp? It's actually very little, because the way it works is that WasmEdge act as the wrapper around llama.cpp. So it actually, through WasmEdge, it acts as a wrapper around a bunch of different inference frameworks. So depending on which hardware you have, because llama.cpp doesn't cover all the hardware options. So we are going to have, so for instance, one of the work we are working with Docker is to cover the web GPU stuff using bird.rs, right? So that would be, say, the AMD GPU and, things like that, which is not currently supported in llama.cpp. But for apple-to-apple comparison, for things that supported in llama.cpp, versus the WasmEdge wrapper around WasmEdge plus WasmNN wrapper around llama.cpp, I think the performance is very close. It's within 10% because we add very little overhead. Because most of this, especially on the fast GPU, most of the work is done on the GPU. We just from WasmEdge point of view, it provides the compatibility. So it transforms the command and the payload into a format the underlying library can understand. And once we do that, the underlying library, which is llama.cpp, actually does most of the work, right? But our benefit is that we don't have to use llama.cpp. We can, depending on different hardware, we can have other choices, right? But when we do use llama.cpp, the performance number are very close, within 10%, I have to say. Okay. And okay, so we can run it on Kubernetes as well. Yes, so we actually are going to have two ways to run on Kubernetes. We're gonna have run WASI, which also goes into Docker Desktop, and we are also working with Red Hat because WasmEdge is included in the Fedora upstream packages, so it's in Red Hat Enterprise Linux and also in OpenShift's RPM distribution packages. So they took a different route. They don't use run WASI. They use CRUN. So we have CRUN integration. So by giving CRUN the ability to load not just WasmEdge but also WasmEdge plugins, we can have those AI workloads goes across the OpenShift cluster as well. So from the end user's point of view, they don't need to worry about any of this. They just open up OpenShift and send in the WASM file, and that's it. The WASM file gonna magically run on all the devices that's in the cluster, right? Because all the devices in the cluster are gonna have the correct version of WasmEdge and the plugin libraries installed. So yeah, that's the beauty of it. That's the beauty of abstracting the interface and decouple that from the underlying hardware, right? Okay. So working towards connection with Llama Index, is that actively? Yes. So we have actually two connectors, so we have a Python connector and also a web-based connector. All those works are open source. So if you are interested, I can point you guys to the code repository that we are working on it. So yeah, that's I believe we have a demo, an internal demo working that is Streamlit plus Llama Index plus LangChain plus WasmEdge. So the WasmEdge currently run through a Python wrapper. We use Python to start WasmEdge, but we could also have LangChain's HTTP connector to connect to the API server I just demonstrated, right? So there's a variety of different ways to do that. Yes. Okay. So how is that possible? A team is paying for the API usage? No. So the whole idea is we don't use OpenAI at all. We just use the OpenAI compatible API. So we are actually running open source large language model. It's released by Facebook. It's called Meta AI now, right? So they released those open source large language models, and a lot of people fine tune them by giving it new capabilities. We can just download it onto our own server, and then start a web server on top of it. The web server behaves like an OpenAI server, but it's not an OpenAI model. So so that's how we do it. Yeah. All right. Yeah, that's I think those are the questions. So we have a couple more minutes left. If you have if you have other questions, please feel free to ask. In the next community meeting, we're going to try to get some outside speakers. So maybe to have someone talk about component model, or maybe to talk about our Dapper integration, where we also made a lot of progress. So some of you may know that people use WasmEdge in the microservice environment, where we use the Dapper sidecar to provide a lot of those infrastructure services, like hundreds of databases, hundreds of key value stores to the WASM application, right? So our Dapper connector has recently been admitted into the Dapper sandbox, and there's lots of well, there's some exciting work that's going on there as well. So that's yeah, that's so. I think one thing to really get involved is to help us test those large language models. So as I mentioned, on Hugging Face, I can see close to 2,000 different Llama 2 based fine-tuned models. It'd be nice to because each of them, when you run them, each of them requires a little different configuration. They require different chat templates. Sometimes that it was enclosed by the square bracket in INST instruction. Sometimes it was there's chat ML and things like that. They're just trained with different formatted data sets. So to figure out how to run them, and then to run some benchmark, like Jay has asked, is it how much slower it's going to be compared with llama.cpp? My answer is within 10%. But is that really true? So we're gonna have a repository that asks people to run this and submit the benchmarks back to us. So those are, and also to develop your own RAG applications on top of that. I think that would also be one of the things we would really like to see and really like to feature. On our Twitter and our social media and our website as well. So yes, let me show you a web page. Hold on. All right. Let me show my screen. Okay. Yeah. If you can see that, sorry, it's the URL is state slash LLM, instead of run-llm, you can have LLM. We're gonna cross-reference those two pages. So, so it talks about different ways to run those. So you can see the supported models. It's not complete. Those are the ones that we have articles for, right? So for instance, OpenChat 3.5, so we have a nice article here. It says, the steps, download the model, install WasmEdge, download the model, download the inference application, and start the inference application, show you, and download the API application and run the API application. So those, so for each of those models, we have an article like this. And let me show you where I say it's so. So for instance, here, it starts the application is always the same. It's a llama and chat.wasm. It's the same application for all the models. Like I said, it's portable. It's agnostic to the underlying hardware, software, and it's also agnostic to the model itself. But there's a template called open chat. That is that defines the specific format the model requires. And it also says when you see the sequence of this, stop generating. So those are the things that are required by this model. So if you don't have this, the model gonna keep generating. It's gonna answer this question and then ask itself another question and start generating until it fills up all the context window, right? So so you don't want that. So you would want it to stop right there. So there's lots of different models has different things. You just have to read the model documentation and try it, right? So here we have a number of those. Those are the ones that we actually have articles written about them, and we also have a bunch of those that's in pipeline that has. If you look at the command line tool that I just showed, there's 26 models to choose from, I think, right? So there's not 26 here. It's 1, 2, 3, 4, 5, 6. There's only 12 here. So so we, but like I said, on Hugging Face, there's over 2,000 of those. So so there are there are a lot of models that we would like to run and demonstrate. The ecosystem just growing so fast. Yeah. All right. Let me see. There is a WasmEdge Hugging Face account. Let me see. Oh yeah, that's so. Yeah, that's. Thank you, Vivian. Yeah, that's. That document is good. That shows all the model instructions. We need to organize those those files. So. So they're all in the same place. So if I say Hugging Face, I think where's Wasm? Oh yeah, there's a WasmEdge. I thought we have. Oh, okay. So most of the models are actually in second state. Yeah. So for the models that we a lot of those other people have quantized them. So they they exist in different repositories, but there are some that we had to quantize ourselves. So we put those into our own repository. So those are the say this neural chat is Intel's model based on Llama 2, right? So it's typically only the chat template is like this. It has 3 pounds space system semicolon, and then a new line, and it talks with us with the system prompt, and then the user question, the assistant answer, user question, assistant answer it can be a symbol like this, right? So each one has a different chat template, and so for this one it's really easy. It just has one GGUF file. So the second state have all this, and if you are interested, there's in the WasmEdge repository we have something called No, I don't think that's one. Maybe it's in my own, in my own repository. Yeah, this one. So that's one I demonstrated at KubeCon in Chicago. So it's a Llama 2 model. We fine-tuned it with the WasmEdge documentation so that it knows things like WasNN refers to the neural network. So if you don't fine-tune it like this, ask it what is WasNN, it's gonna make up some answer. It's gonna tell you something that is completely random. But correct sounding, it's gonna give you a medical term, and something like that, right? So it's but with if you fine tune it with some kind of knowledge, it's going to be a lot better. Yeah. So yeah, that's lots of activities. That's please do reach out to us. Maybe offline if you see things that you'd like to contribute. Documentations, integrations, or building applications on top of our framework, because that's something we are particularly interested in, because that allows us to identify the gaps in our tooling. Because once people start to build applications, they would see, okay, this is missing, that is missing. We really appreciate that kind of feedback as well. So. All right, so I guess we are almost at the time. That's thank you everybody for participating, and you have for you guys in North America, have a really great Christmas and New Year, and for those of us in Asia, the holiday season starts on the New Year day, right? So we're gonna have a couple months of holiday celebrations, and hope everybody enjoys their time with family and all that. And so the next community meeting would be in January, and it'd be a whole new year, and we let's hope we would make more progress on all the things we talked about in this meeting. All right. Okay, thank you guys.